Moving on to the equipment side of things. So the heat pump water heater model that is now included in BEopt is based on a lot of work done at NREL, laboratory evaluations, and also field monitoring done by Building America teams. So lab testing was used to create a detailed transist model that was then used in turn to create a simplified model for Energy Plus for use in BEopt that can still use hourly time steps, yet accurately represent heat pump water heaters. And the field monitoring was used to inform and validate these models along the way. So as a good heat pump water heater model should, this model accounts for how the heat pump performance changes as a function of surrounding conditions and the tank temperature. It accounts for the using electric resistance elements when there's large draws or you're outside the operational temperature limits, and also accounts for interaction with the building, including the effect it has on heating and cooling loads and tank standby losses. I should point out that when you select the heat pump water heater option in BEopt, you'll be using a different hot water draw profile, and the draw profile used will be a stochastic event-based draw profile that was generated using the domestic hot water event schedule generator tool. And again, this is only when you select a heat pump water heater. And you can see an example of the draw profile, an example week here that shows that there is day-to-day variation, and some days have more extreme events where you'll more likely trigger the electric resistance elements to be used. And there's one of these profiles for each level of occupancy, as indicated by the number of bedrooms. And this draw profile, this year of events, is constant from one simulation to another. So the options that are included with BEopt are generic models. There's a 50-gallon model and an 80-gallon model, and these are not meant to represent specific manufacturers, but rather show a range of performance that you can achieve with heat pump water heater technology. And if you want, you can examine the details of these models in the option editor. There's different, the two models have different compressor capacity and efficiency. And the curves used are valid for units that use refrigerant R134A and have a wraparound heat exchanger. And there's also different control logic for the two built-in options. And the options, the location for the options is set to auto, which means that if the building has a basement or garage, the water heater will be placed there, and if not, it'll be in the living space. You can create your own user options to change the location to be specifically in a basement or specifically in a garage, if you like. And I listed some of the lab testing report that a lot of the data that's in these models is based on. One other thing to remember with heat pump water heaters is while there's a method for auto-sizing conventional water heaters that's in the house simulation protocols that's based on number of bedrooms and number of bathrooms, it's more complicated for heat pump water heaters since the ability that they have to deliver hot water is more sensitive to tank volume than conventional water heaters. So the user must select options that are appropriately sized to provide hot water. And this ability to deliver hot water will change with climate, with tank volume, set point, and draw patterns. So I'll show an example. To help users select an option that will be appropriately sized, we introduced a display variable that's shown next to the options in BEopt called %unmet showers. So you can see there's the 4 heat pump water heater options, and this metric, %unmet showers, is an estimate of the amount of annual showering time where the hot water being supplied is below 110 Fahrenheit, which is what we assume the desired mix temperature coming out of the tank should be. So in this case, I think this climate might be Atlanta, Georgia. The 50-gallon, 130 Fahrenheit set point case will have 1.5% unmet showers, which might be which is probably unacceptable. So you can remedy this by increasing the set point to 140 degrees Fahrenheit, or by increasing the tank volume to 80 gallons. Or the second column of values shown is an estimate of the percent unmet showers using low-flow shower heads. So that is a third way you can remedy the situation. So there's different ways that the capacity of the heat pump water heater can be increased. So that's why we left it up to the user to select appropriate options with the guidance of this metric.